Start here. There'll probably be more people joining us as we go, but we'll go ahead and start. Um, I'm Carl Olivier Gooch. I'm a professor in mechanical engineering at the Vancouver campus. My co-presenter is Professor Claire Yan, who is professor of mechanical engineering in the School of Engineering at the UBC Okanagan. So we're here today, along with a couple of staff members and students who we'll introduce later, to talk to you about what mechanical engineering is and how the programs in mechanical engineering work at both campuses. So what is mechanical engineering? Mechanical engineering is fundamentally the study of movement and energy. So mechanical engineers analyze, design, produce, and maintain systems that involve movement and energy, whether it's energy production or use of energy to do useful things. So mechanical engineers end up working in basically every industry, designing machines like robots, aircraft, and artificial knees, for example, working on solutions in clean energy, energy production, reducing greenhouse gas emissions, things like this. The short version is if it moves, a mechanical engineer was involved in designing it, chances are. Claire.
All right, so now you know what mechanical engineering is. So let's see how you can tailor your degree to your passions through options and concentrations. Next slide, please. So both campuses offer Bachelor of Applied Science degree in mechanical engineering. The general program gives you a broad foundation with flexibility to customize your experience. You may choose from various options and concentrations. So for example, aerospace, available on both campuses, dives into aircraft and space flight technology. So if you're interested in health-related pathways, Vancouver has biomechanics and biomedical devices, and Okanagan campus has biomedical engineering concentration. So where you will actually learn how to design medical devices to improve human health. Next slide, please. So Vancouver campus also has energy and environment option. So you will learn renewable energy, building design, industry and transportation systems. And this option is perfect if you're passionate about protecting the planet. Mechatronics, available on both campuses, combines electronics, AI, programming, and mechanical systems to create innovations like robots. Vancouver campus also has naval architecture and marine engineering, which focuses on ship design, hydrodynamics, and marine systems. Next slide.
So the one question I'm sure many of you have is, what could I expect to do in my degree if I'm in one of the mechanical engineering programs? How does that all work? Well, on both campuses, there's a common first year in engineering. And then in second year or before second year begins, students select their specialization. So on the Okanagan campus, students select their specialization and are guaranteed placement into their first choice program. On the Vancouver campus, our programs tend to be space limited, and so we students express their preferences and are matched into programs accordingly until those programs are full. So our second year program here in Vancouver is an award-winning program called MEC 2 that is designed to break down the barriers between the traditional subject areas within mechanical engineering, so that students are better skilled at applying ideas across those boundaries that used to exist in our program. On both campuses, in third and fourth year, you have opportunities to specialize and lots of opportunities to design things. All of the specialized options that Claire talked about begin in third year. Most of those options, in addition to having some courses that are required for the option, also have a number of technical electives available so that you can choose things that are of particular interest to you. Both programs have multiple design courses. multiple design courses, both in third year and in fourth year, including a major capstone design build project on both campuses. And both campuses also have specialized facilities and support for designing and building things, machine shop, instrumentation lab, maker space, and of course, a great team of student services staff. Our professors are experts in their research areas across a wide range of topics, including sort of historically fundamental areas like applied solid mechanics, fluid mechanics, newer areas like computational engineering, and other specializations that are more focused on specific applications. So biomechanics and biomedical engineering, manufacturing automation and robotics, mechatronics, energy and the environment, naval architecture. And we also have folks doing research in engineering education. How do we better teach engineers so that they can be better at what they do, and therefore better able to contribute to society. So all of our researchers are using tools from mechanical engineering to investigate issues of societal importance, ranging from medical issues like concussion, cancer, and ultrasound technologies to things that are more energy and environment related, air pollution, transportation systems, including sustainable ships, fuel cell power, things like this, and a fair number of people who do things in robotics and human-robot interaction. Okay.
So what can you expect from your student experience? Next slide, please. So beyond classes, here's what makes UBC exciting. Your student experience will be vibrant and supportive, with both campuses fostering a strong sense of community and hands-on learning opportunities. So in Vancouver campus, you can join Club MEC, which is our undergrad student society, or you can dive into design teams like UBC Aero Design, which builds payload carrying planes. So if you love cars, we have design teams like Formula UBC, UBC Formula Electric, and UBC Solar for you to choose from. They build amazing race cars powered by, for example, combustion engine, powered by electric power, or powered by solar energy. Next slide, please. So in Okanagan campus, NSOC is your undergrad society advocating for engineering students and building a strong community. So if you have a passion for aerospace, our aerial robotics and rockery club is perfect for you. It designs drones for real-world applications like forest firefighting or mapping. So if you love cars, please check out our Okanagan Motorsports design team. And we also have other amazing teams, such as marine robots, heat robots, Great Northern Concrete Toboggan Race, etc. So many of these design teams or design clubs compete internationally, and you will have opportunities to connect with industry experts. So by joining design teams and clubs, you not only hone your technical skills, but also build teamwork and leadership abilities. Next slide, please. So if you love discovery, dive into research early. So in Vancouver, take academic research courses like MAC 493, MAC 494, in fourth year, and will you do research projects supervised by professors. So in Okanagan, over 100 undergraduate students participate in faculty research annually. So both campuses offer undergrad research awards such as NSERC USRA or NSERC IUSRA, which is for international students. So through those paid work terms, you can build research experience, which is perfect for strengthening your grad school or job applications.
Now, another obvious question from your point of view is, what career options can I pursue with my degree? Well, the answer is pretty broad. Our alumni work in a variety of industries, typically starting out in engineering, but many of them progressing to positions in management as they spend more time in the workforce. So job titles start out with things like mechanical engineer, project engineer. This is what the job posting says as the tagline. But as they go along, some of them work their way up to be a chief technology officer or chief executive officer at a company. Um, and the companies that they work for, many of these are household names, right? You've heard of a bunch of these companies. Some of them are located here in BC. Some of them are across Canada or around the world. Some of our alumni aren't satisfied with going to work for someone else, and they have an idea for something they think would be a great product. Often this comes out of their capstone design project in fourth year. And so they graduate and start their own company. We've got a few examples here on the right. Um, these are some of the people with CEO in their job titles, right? They went to work for themselves right out of school and have built successful companies that they're now running. So I'm going to close with a quote from one of our graduates. I chose mechanical engineering because it gives me a strong and a broad foundation to do a lot of things in the future. It keeps my options open. I didn't know what I wanted to do in high school, but I knew that this degree would give me tons of options and I could combine it with other disciplines.
All right, so this is the end of our presentation. Joining Carl and me are two students from both campuses. So Richard and Sienna, can you please introduce yourself? And after that, we're going to answer your questions.
Yeah, I guess I'll go first. Hey, I'm Richard. I am a fifth year mechanical engineering student at UBCV.
Hello, everyone. My name is Sienna, and I'm also in my fifth year, but I study on the Okanagan campus.
All right, so if you have any questions, please submit your questions in Q&A and upvote the questions you'd like us to answer.
So the first question there is someone is asking about about Vancouver motorsports teams.
Yeah, so on the Vancouver campus, we have we have motorsports teams, plural. They're folks building a variety of cars. There's the Formula SAE team is building an open wheel race car that looks like a mini version of an Indy car or a Formula One car. There's a Formula Electric team that is doing the same thing, but using an electric motor instead of an IC engine. There's a Baja team that builds an off-road car for a competition. There's UBC Solar that's building a solar car. There's UBC Super Mileage that builds a super aerodynamic, high efficiency vehicle. The last time I saw the numbers, they were getting, I think it was close to 2,000 miles a gallon with that thing. It's crazy. It doesn't look very comfortable to sit in, but it's super efficient. I may have left out one or two. If I have, I'm sure Heather will correct me, but I just listed off 5 there. So there's plenty of opportunities if that's your thing.
Great. Another student is asking, what would one expect for first and second year courses and workload? So I know Alex typed in specific things around courses and labs, but I thought maybe Sienna and Richard could just talk a little bit about their experience in first and second year and courses and workload.
Yeah, I can go first. On the Okanagan campus, it's a general first year, so everyone's kind of in the same boat. So this isn't necessarily specific to just mechanical engineering, but all the engineering disciplines. Typically, your courses have 3 hours of lecture a week, so 2 1.5-hour lectures, and then you also have a tutorial. In addition to that 1 hour tutorial that happens each week as well, You have a lab. Labs tend to be bi-weekly and they're anywhere from 2 to 3 hours long. It really depends on the course. Not all courses have labs, but labs is just hands-on learning of the concepts that you've learned in lectures. And so in terms of in-class time, that kind of covers all of it. You have lectures, tutorials, and labs. And then outside of class, obviously you'll be studying for midterms and exams. Whether or not a course has a midterm or 2 midterms or has quizzes or pop quizzes or how many assignments they have, it really varies a lot between courses. And so you'll know once you get your syllabus, which instructors give at the start of the term. Hopefully that helps.
I actually didn't attend my first year in the Vancouver campus, so I can't really answer for the Vancouver campus first year. I also was in Okanagan campus my first year, and I transferred over to Vancouver campus later in the second year. I attended during the COVID years, so the curriculum from Okanagan and Vancouver campus first years was quite different. I believe that the Vancouver campus has courses that's basically taken from other departments like physics, math, while in Okanagan, outside courses generally take over the first year. You do not have like separate math courses. It's like outside, all outside courses, base courses. For second year, you generally would take something called engineering concepts for 1, and in second semester is engineering concepts 2, where it's a combination of different courses. So for the first year, there's solid mech, circuits, dynamics, and mathematics, materials. These courses are taught every week, and you would be tested on these topics every week. Usually it's tested dynamics math is that circuit tested together, and solid mech and materials tested separately in the second week.
Great, thank you. The next question is, how hard is it to get into mechanical engineering after first year? What average do I need? And so I'm guessing that's based towards Vancouver, because I believe, Claire, correct me if I'm wrong, they will automatically get into mechanical engineering if they select that at UBCO.
That's right. Yeah.
Yeah, so on the Vancouver campus, the placement for second year is the priority for placement is based on GPA. So the simple version, at least, is they take everyone and sort them by GPA and go down the list. And if your first choice is still available, when they get to your name, they put you in that. Otherwise, they put you in your second choice, and so on. It's a little more complicated than that because most programs, I think, and we're certainly one of them, we're at least as interested in how good a fit mechanical engineering is for you and vice versa as we are in your GPA. And so there is an essay that you write as part of that placement process that we read and provide feedback to student services so that they can reprioritize based on that. So if there's something about your past experiences or about what you want to do after you leave university for which mechanical engineering is the perfect thing for you, write about that, and we take that into account. So in terms of raw numbers, that number runs, I can quote Heather from the previous session, it depends on the year and what other students in that year wish to do, whether the physics midterm was really hard in the first semester and everybody dropped 2 points of GPA because of a too hard midterm or whatever it was. The numbers go up and down. We see them as low as mid-70s and as high as mid-80s. So, your goal really should be go into first year, learn all the things that you're expected to learn, because the reason it's in first year engineering and everyone's taking it is it's going to be useful to you, whatever program you end up in. And do as well as you can, put in your request for a program in the second year and see what happens.
Great, thank you. We have 2 minutes left. Last question on the board is, what research are you doing in your last year?
Maybe I'll answer this question. So in UBC Okanagan campus, you don't have to wait until the final year to do research. Actually, research you can actually connect with your supervisor or the professors to start to do research even at the end of the first year. So this is what most of our students do. So they reach out to professors and they start to build connections. And once they find, for example, common interests, they can start to do the research with their professor, even in their at the end of the first year or starting of the second year. So the type of research will depend on personal interest as well as whether the professor has some fundings for you.
Well, for Vancouver campus, you can always ask, similar to Okanagan campus, you can always ask your supervisor, your professor, whether you can join in on his research. For example, in my second year, I had the difficulty to actually find a co-op job during summer. And I asked one of my course instructor, Sheldon Green, to join his lab as I was interested in his research direction of applied fluids. And during the summer, I spent 4 months intensively and very intriguingly working at his lab.
Great. Thank you so much for all our speakers, and thank you to everyone for attending. We are at the end of the session. We hope you all enjoy the rest of the event, and we look forward to seeing hopefully some of you on our campuses in a couple years. All right, thanks.